Number 6A. In what situation does the ideal gas law apply? Well, when the gas sample undergoes no change in conditions, right? No change in conditions. Notice that PV is equal to nRT doesn't have anything like a P1, P2, no V1, V2, no N1, N2, no T1, T2. There's no change in conditions. All the conditions are the same. There is no change in conditions. So this is a state function, right? We're talking about one particular state of conditions. Okay? So if there is any sort of increase or decrease in any of these quantities, a change, we're not going to be using the ideal gas law. So we use the ideal gas law when the gas sample undergoes no change in conditions and when 3 of those 4 variables are known, right? Pressure, volume, temperature, number of moles. When we know 3 of those, we can solve for the 4th one. B. Why do you have to pay particular attention to the units when using this law? Well, the units for volume, temperature, and pressure must match those of the gas constant that's used. Right? I try to make a little bit of a deal in the video lecture, and your textbook has an entire heading dedicated to the ideal gas constant. And the takeaway here is the value for that constant will change based on what units you're using. It's not that the constant itself is anything but constant. What we're changing here are the units that we're using to describe that value. And because the units change, the values that are associated with it change. And so it's kind of a weird concept. It is a constant. It is always the same. But we can express it in different units. And so we have to be sure that whenever we're doing calculations with the ideal gas law, we have to use that value for R. Whatever value for R we're using has to match the units of all 4 of the other quantities being used.